What's up everyone? Welcome to Lowered Expectations. Thanks for lowering your expectations and hanging out with me here. I do appreciate it. In today's video, I am going to be doing some more modifications to my CNC milling machine frame. This is a video in a series of videos where I'm converting my manual mill over to operate on CNC. In this particular video, I'm going to be installing these leveling casters that Vevor sent me. Installing these leveling casters from Vevor is not going to be a big project, and I'm not going to go into great detail because your application is going to be a little bit different than mine. So I've decided that in this video, I'm going to talk a little bit about why I decided to upgrade my milling machine. Those of you who saw my unboxing video of the Precision Matthews PM-30MV will have noticed that I already had a milling machine. That is an RF31. I talked a little bit about how the new mill was better than the old one, but I didn't explain at all why I am not using it for this conversion. So in this video, we're going to go into a bit of detail on that. I could absolutely weld this upright, but to make my life a little bit easier, I'm going to flip the frame over. Ta-da! As a quick side note, before we get into this video, I recently did a screen recording for the Vevor Black Friday sale, and it turned out to be very amusing. We looked at some of the amazing deals like sales on welding wire, and we also looked at some of the weird, wacky, and wonderful products that they have. They have an amazing variety of stuff. If you haven't seen the video, go check it out. If you haven't checked out their website, use an affiliate link and do that. If I'm doing my calculations correct, the outside of this should be 34.75. So let's see if that's anywhere close to right. 34 3/4 right there. And let's check on this side. Just gonna mark this. This stuff doesn't have to be exact. Immediately after I found out these things existed, before I even knew Vevor had them, I was disappointed that they all had plastic wheels without bearings. Then I did a bunch more research and found out that even the really expensive ones use nylon wheels without bearings, and that they're actually able to support a huge amount of weight. I was quite concerned about this, but it turns out that nylon is actually the standard, and it works very well. These casters are rated for 550 pounds a piece, so I shouldn't have any issues. Thanks to Vevor, not only do I have leveling casters for my frame, but I also have an extension cord for my welder. That means that I can weld the frame anywhere that I want in my garage, and so I'm going to choose to weld it directly underneath my ventilation fan inlet. And I'm going to do that because it's a little bit chilly today and I don't want to open all of the doors and windows. Beautiful. Started off a bit rough. I spent a whole lot of time trying to figure out what I was going to do for leveling feet on my milling machine frame. The mill itself weighs about 500 pounds. By the time you add a vise, some tooling, and an enclosure, you're probably looking at over 700 pounds, and that's not taking into account what you're actually going to be milling in the machine. So it needs to be very secure, very stable, and also very adjustable, because if the mill is not sitting flat, it's not going to cut properly. The Vevor casters come in a box of 4. Pretty plain packaging, no reason for it to be fancy. And apparently I opened it from the bottom. I have a habit of doing that. They look to be powder coated with a hammer tone finish. I'm going to have to sand off a little bit of the powder coat on the part that I'm going to weld on, but that is to be expected. Wow! The weld that's right up front is the absolute worst piece of trash weld I've done in a long time. Wow! Why did that happen? I used Fusion 360 to design my milling machine frame, and because Fusion is linked to the McMaster-Carr catalog, I went on there browsing for a leveling solution. What I found is that there exists such a thing as a leveling caster, and I thought to myself, that is a genius solution and exactly what I need. I have very limited space, and I'm going to need to move probably 1,000 pounds of milling machine away from the wall to do maintenance and cleaning and all sorts of other stuff, and so this is exactly what I need. And then I looked at the price of the McMaster-Carr leveling casters and thought to myself, maybe I can get these somewhere else. With my newfound knowledge, I quite excitedly typed leveling casters into the Google search engine, and wouldn't you know, one of the first things that popped up was Vevor.ca. That is right, Vevor has these amazing leveling casters, and quite fortunately for me, they are in the middle of a Black Friday promotion. I've already done 2 videos, one on a diesel heater install in a Toyota 4Runner, and one on an extension cord that I used to do some welding on this milling machine frame. This is the last video in the series, so if you guys haven't already heard, Vevor's having a Black Friday sale November 13th to November 27th. If you haven't already visited their website, I would absolutely recommend doing so. Please use an affiliate link so that they know that I sent you, even if you're not interested in these casters. If you are interested in these casters, affiliate link and discount code in the description below. This part of the project is done, and I am quite excited about it. I'm also proud of myself because I didn't go way overkill on welding these things on. I've got 2 beads of weld run down each of them. I've got a bead here and a bead here, and on the end ones I've got one along here and one along here. The loading when the machine is actually sitting on the feet is straight down. When you're loaded on the casters, there is some torquing to it because the wheel is off center. That's how casters work. But yeah, obviously this weld is going to hold. One of the things I was wondering about was whether or not I would be able to turn these adjusters for the leveling feet with the weight of the mill and the table on it. And I think it's pretty clear that the answer to that is no. I highly suspected that would be the case. There are several different ways around this that I'll show you guys in just a minute, but first I'm actually going to try it with my fingers and see how it works. So we'll It's actually up on the rubber pad now. I can turn it, and okay, it's lower now. We're onto the rubber pad, and I can turn it with my fingers. You can get fingers on both sides. It's open on the front and the back here, and so I can turn it and get the actual caster off the ground. But I suspect with several hundred pounds on this, that is going to be very difficult. So I'm going to show you guys how I plan on doing this once the milling machine is actually sitting on the table. I actually prepared for this in advance because I thought it was going to be even harder than it is. I've got a block of wood and a pry bar. Leverage is your friend. If I just tried using the pry bar on this, it would just slip and slide around. The block of wood not only gives me a bit more height, but a good grip. So I could do this in a couple ways. I could use the rocking end of this and actually just do it like that. That would actually work in my case. But the block of wood gives me a bit of extra height, and I can do that. And even if this thing was probably 2,000 pounds, I could probably still lift a corner of this and adjust it. So this is definitely, I suspect that this is going to be the way that I need to adjust these leveling feet once the milling machine and all the other equipment is sitting on top of the stand. Okay, let's roll it into the corner and see how well this works. Well, that is pretty much effortless. I can tell you right away. I'm not sure how well it shows up on camera, but this thing moves around pretty much effortlessly. Of course, it is going to weigh several hundred pounds more once the milling machine, chip pan, enclosure, vise, tooling, and possibly some parts are sitting on there. But I am not concerned with it at all because in its current configuration with 6 casters, it is rated for 3,300 pounds. So I don't think I'm going to get anywhere near that limit. I have a huge amount of work to do before I need to worry about leveling my table, but now that part of this project is taken care of. I still need to convert my mill over to CNC, which means taking it apart and cleaning it, installing a ball screw kit, installing servo motors, installing all of my electronics into an electronic enclosure, and then figuring out software and all sorts of other things. So, that being said, I'm not going to leave this sitting on the nylon caster wheels. I think it's probably okay, but I don't want to get flat spots in my wheels. So anytime this is sitting, I'm going to crank down the leveling feet so that it's actually sitting on them. Before we move on to talking about why I decided to purchase a new mill instead of converting my old one to CNC, I want to say a huge thanks to Vevor for sending me these leveling casters. As you guys have seen, I am confident enough that these things will work flawlessly for the next several years that I went through the trouble of welding them in place instead of using the bolt holes that they come with. So, if you guys are interested in purchasing a set of these, of course, there's an affiliate link in the description below, as well as a discount code. If you're not interested in these, use that affiliate link, head on over to Vevor and check out their website. As I've already mentioned, they have a Black Friday sale going on between November 13th and 27th. They have a ridiculous variety of stuff. If you haven't seen my video where I talk about all the weird stuff that they have, not all of it, but some of it, go check that out. A few of the things on the list were a bouncy ball that you get in, and what was one of the other things? Exhaust manifold for an LS for $135. I'm going to try not to go into a whole bunch of detail about milling, and I'm going to try to keep this fairly short. But to explain to you guys why I purchased a new mill instead of using this. This is my old mill, the RF31. I've used this for 9 or 10 years and I love it. It's great for a home shop, but it does have its shortcomings and it has a few things working against it if you wanted to convert it to CNC. The first thing being the spindle speed. If you want to change the speed of the spindle on this particular mill, it is almost exactly like a drill press. You open up the cover on top, which exposes a set of pulleys and the motor. There is a knob back here that you loosen the motor off with. You move the motor, that gives you slack in the belt. You change the position of the belts, you retension the motor, you close the lid, and you are now in a different speed. Because the motor on this turns at one constant speed and you are using belts and pulleys to change the speed of the spindle, you are limited to a certain number of speeds. It's not infinitely variable. We are now going to take a little bit closer look at the pulley system on my milling machine so that I can explain to you guys that while this thing has a claimed spindle RPM of between 150 and 3000 RPM, on paper and reality aren't always the same thing. I have no doubt that this will actually turn 150 and 3000 RPM. In fact, I've actually done it, but I wouldn't want to do it for a long period of time, and I wouldn't want to expect it to put out a lot of torque at those RPMs. And now I'm going to show you why. We are currently somewhere in the middle of the RPM range, and because we're in the middle of the RPM range, we're actually using the middle pulleys. The belt is engaged with fairly large pulleys on the motor, on the intermediate, and on the spindle pulley. Large pulleys are good because they have a large surface area. That means you can apply a lot of torque through them. And also because they're large, you don't have the belt bent at a very tight radius, which means you're not creating a lot of extra heat in the belt just by rotating it around. You might be able to see where I'm going with this, but I'm going to continue anyway. As soon as we go to either end of the extremes, whether that's the 150 or 3000 RPM range, all of a sudden we have to start using these small pulleys. And when we start using these small pulleys, that means we are bending the belt around a very tight radius. It creates a lot of heat in the belt just by rotating it around. And also because there's a very small surface area, we can't apply a lot of torque to it without it slipping. If it does slip, there's not much surface area to distribute the heat or to get the heat out of the belt, so you're much more likely to cook a belt. This is especially a problem if you're doing a heavy cut with like a big boring bar, a big mill, or even a big drill bit. Hopefully that makes sense. Another drawback of this is that it is pretty stupid. It basically just has an on and off power switch for the motor. There is no feedback from the motor to tell my computer how fast the spindle is turning, and so there is no way for me to use a computer to speed up or slow down the spindle. And that is important because different size cutters and different type of cutting operations require different speeds. The Precision Matthews spindle speed is infinitely variable between 50 and 3000 RPM, and because it uses this dial, which is a potentiometer, you can actually use a circuit board to connect this to your computer so that the programming can control the speed of your spindle. Not only that, but because it is infinitely variable, you don't have to settle on a number that is close to the right speed. You can actually pick the right speed. Although the spindle speed issues on the RF31 are a little inconvenient when it comes to CNC milling, that is far from the straw that breaks the camel's back. I'm going to try to take a few minutes and explain to you guys in some detail why I forked out the extra cash to actually get a new mill instead of just using the RF31. And the main reason behind that is that it has a square column with dovetail ways. I tried to explain that in my unboxing video, but I don't think I did a very good job. I think I may have caused some confusion in my unboxing video talking about the drill quill feature or the drill press feature on the Precision Matthews. This is actually going to be disabled when I convert it to CNC, and there are a few reasons for that. The main one being that this is a 3-axis machine, or it's going to be a 3-axis machine, meaning X, Y, and Z. So X left and right, Y in and out, and Z up and down. And the Z axis on this is not going to be the drill quill. It is going to be the whole head moving up and down. That just makes way more sense because this has 14 inches of travel and this has 3 inches of travel. This is also more precise because it is on dovetail ways, where this is not. The RF31 actually has a slight advantage when it comes to drill quill travel, but as we've already discussed, we're not going to be using that feature for CNC milling. If it were a CNC mill, we would be moving the whole head. So let's go about this as though we would be doing that. In order to move the head up and down on this mill, it is actually locked to the column. So there are pinch bolts that lock it to the column. And when you loosen these bolts, I've already pre-loosened them a bit so this would go easier for filming, but you loosen off these bolts and then you can lower the head. Well, there's actually a hand crank over here, and you simply turn this hand crank and the head can go up and down. On the RF31, if you want to use a servo motor or stepper motor to move the Z-axis up and down, you can also rotate the head of the mill 360 degrees, which means that you cannot maintain your zero and move the head up and down. So to recap, the RF31 will only allow the head to move up and down if the column is loose. If the column is loose, the head will also swing left and right and you will lose your zero, and you just can't do sideways cutting with it at all. So you are limited to using the Z quill or the drill quill to do CNC milling if you wanted to set this machine up with CNC. That means you're limited to 5 inches of travel, and it's not nearly as rigid, so you're going to get a lot more tool chatter. You're going to have to work slowly, and you're probably going to end up with a lot of broken tools. The Precision Matthews, on the other hand, has this large square column that is quite substantial, and it has dovetail ways, which means it allows the head to move up and down freely while not being able to move left and right. I hope that clears things up and you guys now understand why I purchased a new mill instead of converting my RF31 to CNC. I also hope you enjoyed the video. If you did, please remember to leave a thumbs up. And if you want to see more of this project, be sure to subscribe. Remember that Vevor is having a Black Friday sale November 13th to 27th. If you go to their site and register your email address, they can send you coupons and different offers. They have a lot of great products and also a lot of great deals, so I would recommend you do that. If you do visit their website, use one of my affiliate links, and that way they know I sent you, and they are more likely to send me more cool stuff to test. If you're interested in a set of casters, well, affiliate link in the description below. You can click on that, and there is a discount code down there as well. That is going to do it for this one. If you guys have questions about this project or this mill, or I wasn't clear about something, be sure to let me know and I will do my best to answer. I will see you next time.